Welcome to qnawire.
So we can say that the amount of thermal energy lost would be equal to the mass of the water times the specific heat of the water times the change in temperature of the water. And this would be equal to 0.25 kilograms times 4,190 joules per kilogram per Kelvin. And then this would be times 40 minus 75 degrees Celsius. And we find that Q lost is going to be equal to negative 41,825 joules, and this is in cooling the water. So that's how much thermal energy must be extracted in order to bring down the water temperature. We know that the thermal energy gained from the ice is going to be equal to the negative thermal energy lost. So essentially, we can say that the mass of the ice initially is the mass of the ice times the specific heat of the ice times the change in temperature of the ice plus the latent heat of formation plus the specific heat of the water times the change in temperature of the water would be equal to, again, negative Q lost. So we would have the mass initial equaling negative Q lost, so positive 41,825 joules, and then this would be divided by this entire term here. So we would have 2,100 for the specific heat of ice, 2,100 joules per kilogram per Kelvin, times 20 degrees Celsius, because it started at negative 20 degrees Celsius. The ice started at negative 20 degrees Celsius, plus the latent heat of formation, so 334,000, and then plus 4,190, the specific heat of water, times, again, that 40 degree temperature increase. And this is going to equal 6.74 times 10 to the negative 2 kilogram. Or we can simply say, rather, this is already SI units. So yeah, we would essentially keep it as kilograms. So that would be how much ice is needed in order to cool the water from 75 degrees Celsius to 40 degrees Celsius. That is the end of the solution. Thank you for watching.